Hello guys, welcome to another video. In this question, if you see this question, they have given that the effective stress at the middle of the clay layer after the application of the embankment loading is 180 kilonewton per meter square, and they have given the unit weight of water as 9.81 kilonewton per meter cube. Also, they have given the parameters of sand and parameters of the clay. So they have asked us to find out the primary consolidation settlement. So we'll find out primary consolidation settlement which takes place at the middle of the clay layer, which is middle of clay layer, that is nothing but 3 meter. Okay, right. So solution. So if you see that question, they have given that effective stress at middle of clay layer after the application of embankment loading, which is effective stress sigma naught plus change in effective stress, that is equal to 180 kilonewton per meter square, and they have given the unit weight of water as 9.81 kilonewton per meter cube. So the equation for primary consolidation, which is given by delta H, will be equal to Cc H divided by 1 plus E naught log 10 sigma naught dash plus delta sigma naught dash divided by sigma naught dash. Okay, Cc is the compression index which they are given in the question as 0.25, and H is the thickness of the clay layer which is 6 meters. So we need to find out the value of E naught and we need to find out the value of sigma naught. Okay, so for calculating the value of E naught, we know that Sc will be equal to Wg. Say from the Sevag equation, since they have given the water content and specific gravity of the clay layer, we can easily find the void ratio of the clay layer. Since the clay layer is in the saturated condition, so S will be equal to 1. So 1 and E will be equal to W into G. So water content is 45%, which is nothing but 0.45 into specific gravity of the clay layer is 2.65. So E naught. So we can consider E as E naught, which will be equal to 0.45 into 2.65, that is 1.1925. So if you calculate the effective stress till the middle of the clay layer, for that, see, effective stress till the middle of the clay layer, which gives you unit weight of sand into depth, that is gamma sand into depth 2 meter plus clay layer is in saturated condition, so we need to find saturated unit weight. Saturated unit weight of clay layer into 3 minus, since this is total stress and effective port pressure, minus gamma W into 3, because water layer is present just above the clay layer. Okay, so we need to find out the value of gamma saturated. So gamma sat will be equal to G plus E gamma W by 1 plus E. So G is nothing but 2.65 plus E 1.1925 gamma W 9.81 divided by 1 plus 1.1925, where we will get gamma sat will be equal to 17.1926, that is 17.193. So with this we can calculate sigma naught dash. So sigma naught dash will be equal to gamma sand, that is, which is nothing but 18.5. 18.5 into 2 plus plus 17.193 into 3 minus 9.81 into 3, where we get gamma naught dash as 59.149 kilonewton per meter square. So now we will find out the consolidation settlement. Delta H will be equal to CC is nothing but 0.25. CC it is 0.25 and H will be 6 divided by 1 plus E naught. 1 plus 1.1925 log 10 sigma naught plus delta sigma naught dash will be equal to 180 divided by sigma naught dash is 59.149. So by solving this equation, we get delta H as 0.33 meters. The consolidation settlement will be 0.33 meters. In this question, they have given that void ratio of clay sample M that has been decreased from 0.57 to 0.510 when the applied pressure is increased from 120 kilopascal to 180 kilopascal. And for the same increment in pressure, the void ratio of another clay sample, that is N, decreases from 0.6 to 0.55. And they have given that the ratio of hydraulic conductivity of the sample M to sample N, that is 0.125, and they have asked us to find out the ratio of coefficient of consolidation of sample M to sample N. Solution. They have given the ratio of hydraulic conductivity of sample M, Km is to Kn, that is 0.125, and they have asked us to find out the ratio of CVM is to CVN. So K is nothing but CV MV gamma W. So we need to find CVM by CVN, which is nothing but Km divided by MV of M gamma W divided by Kn divided by MV of N gamma W. Gamma W and gamma W will get cancelled. So we get Km divided by MV of M divided by Kn by MV of N. So the value of the equation of MV, it is given by AV by 1 plus E naught, further expands to delta E by delta sigma naught dash into 1 by 1 plus E naught. So MV will be equal to delta E divided by 1 plus E naught into delta sigma naught dash. So we can find out that MV is nothing but coefficient of compressibility. So MV of M, that is change in void ratio. Void ratio has been decreased from 0.575 to 0.510. 0.575 to 0.510 divided by 1 plus. So initial void ratio is 0.575. And change in effective stress will be 180 minus 120. And MV for N will be equal to change in void ratio as 0.6 to 0.55. 0.6 minus 0.55 divided by 1 plus 0.6 into 180 minus 120. Now we take this value and solve into this equation. So CVM divided by CV of n will be equal to. So if you see here, you can directly take it as Km by Kn into, sorry, Km by mv of m into mv of n divided by Kn, which gives Km by Kn into mv of n divided by mv of m. Km by Kn into mv of n by mv of m. Km by Kn they have given us 1.125. 0.125 into mv of n, that is 0.6 minus 0.55 divided by 1.6 into 60 into mv of n, which is 1.575. I am directly writing with the cross multiplication form. Okay, divided by 0.575 minus 510. 0.575 minus 0.510. So by solving this, we will get CV of m is to CV of n will be equal to 0.9468, which is 0.947 or 0.95. Okay. Question. It is a memory based question. So for normally consolidated soil, over consolidation ratio will be equal to 1. Okay. For normally consolidation soil, over consolidation ratio will be equal to 1. And for quick clay, sensitivity will be greater than 16. For quick clay, sensitivity will be greater than 16. For clay of high plasticity, liquid limit is said to be greater than 50. So the remaining sand in critical state, where dilation angle is greater than, so dilation angle is equal to 0. So 1s, 2p, 3q, 4r. Option A is the right answer. In this question, they have given that a raft foundation 30 meter into 25 meter is proposed to constructed at a depth of 8 meter in a sand layer, and they have given 25 meter thick saturated clay layer. 25 meter thick saturated clay layer exists 2 meter below the base of the raft foundation. Below the clay layer, a dense sand exists at the site, and they also told that a 25 mm thick undisturbed sample was collected from the mid depth of the clay layer and tested in a laboratory odometer under double drainage condition. Okay, and they have found that the soil sample has undergone 50% consolidation settlement, 50% consolidation settlement in 10 minutes. So they have asked us to find out the time required for 25% consolidation settlement of the raft foundation. That is, they have asked us to find out the 25% of consolidation settlement which will happen in the field case. So they have asked us to find out the time required for 25% of consolidation settlement in field actually. So given in lab condition, the depth of clay sample is 25 mm. So they have tested in two-way drainage condition. Sorry, the thickness H. So we will be getting D, which will be equal to H by 2, that is 12.5 mm. And the degree of consolidation, which is at 50, for 50 percentage, it took 10 minutes. So in field case, the thickness of clay layer, that is 25 meter. So for we need to consider the mid of the clay layer, which is D will be equal to 12.5 meter. And they asked us to find out the time required for 25% of consolidation. Okay. So from this, we know that the equation of consolidation settlement TV will be equal to CVT by D square. So for lab condition, TV of 50% will be equal to CVT. That is T they have given us 10 minutes. Okay. They have given T as 10 minutes. CV10 divided by D, which is nothing but 12.5 mm. We should take into meters. So 12.5 into 10 to the power minus 3 the whole square. Now they've asked us to find out in for 25 degree of consolidation in the field. So TV of 25% will be equal to CVT divided by 12.5. Since it is 12.5 meters, we don't need to convert anything. The whole square. Okay. Since the degree of consolidation which is lesser than 60%, we can take TV for both. For TV of 50%, that is pi by 4 into 0.5 square will be equal to CV into 10 divided by 12.5 into 10 to the power minus 3 the whole square, where we get CV will be equal to pi by 4 into 10 into 12.5 into 10 to the power minus 3 whole square into 0.5 square. The coefficient of consolidation will be same for both field condition and sand condition. Okay. So we can, with respect to this, from this equation, we can directly substitute in TV of 25%, which is nothing but pi by 40 into 12.5 into 10 to the power minus 3 the whole square into 0.5 square. So TV of 25, which is nothing but pi by 4 into 0.25 whole square, that is equal to CV into T by 12.5 the whole square, equal to pi by 40 into 12.5 square 10 to the power minus 3 the whole square into 0.5 square into T by 12.5 square. 12.5 square, 12.5 square will get cancelled. So pi and pi will get cancelled. 440 10. So by solving this, we get T will be equal to 25 lakh minutes divided by 24 into 60, because they've asked us to find out the time required for 25-degree consolidation in days. Time in days. They've asked us to find out the time in days. Okay. Which gives approximately 1736 days. The answer will be 1736. In this question, they have given that initially the total vertical stress. So initially the total vertical stress and pore water pressure at point P, which is 150 kilopascal and 25 kilopascal. So due to construction of a building, there will be an additional total vertical stress of 100 kilopascal at point A. So they are asking that what is the degree of consolidation of clay layer at P when the vertical effective stress at P is 175 kilopascal. So we'll write down the given condition. Given initial total vertical stress will be equal to 150 kilopascal, initial pore water pressure which is equal to 25 kilopascal, and change in total vertical stress will be equal to 100 kilopascal, and they have asked us to find out the percentage of consolidation at effective stress, which is 175 kilopascal. So we'll write down the solution. The equation of degree of consolidation percentage U is given by Ui minus U divided by Ui into 100, where Ui is the initial excess pore water pressure and U will be change in excess pore water pressure at given condition. Okay, so if you see this question, the initial excess pore water pressure will be accommodated by the additional total vertical stress. So initial excess pore water pressure, because they have given the initial pore water pressure of 25 kilopascal, and when suddenly a load acts, the pore water pressure will be, the excess pore water pressure will be accommodated by the load acting on the soil. So initial excess pore water pressure will be equal to change in effect total stress or the load acting. Okay, so that is equal to 100 kilopascal. So if you see this question, they have given the initial total stress as 150 kilopascal and change in stress, total vertical stress will be equal to 100 kilopascal. So final total vertical stress will be 250 kilopascal. And also they have given the with the initial effective total vertical stress and initial pore water pressure, we can find out the initial effective stress. Sigma naught will be equal to sigma naught minus u naught, that is 150 minus 25, which is nothing but 125 kilopascal. So from this we can calculate that change in effective stress. Change in effective stress will be equal to change in total stress minus change in pore water pressure, which is nothing but U. Okay, so change in effective stress will be given by 175 minus initial effective stress, that is 125, and change in total stress, change in total vertical stress will be equal to 250 minus 150 minus change in pore water pressure. So delta U will be equal to 100 minus 50, which will be nothing but delta U will be equal to 50 kilopascal, which is U. So with this we can calculate the percentage of consolidation. So percentage of consolidation U will be equal to UI. UI is nothing but 100 minus U is nothing but 50 divided by 100 into 100. So the percentage of consolidation will be 50 percentage.